Welcome to Ask and Learn.
Let's find the absolute minimum and absolute maximum values of the function f of x equal x to the negative 2 times natural logarithm of x on the closed interval from 1/2 to 4. So first we know that this function is continuous on the given interval because the point x equals 0 is not there, and in fact the natural logarithms are defined for positive values of x, but here we have an interval which is completely on the positive values of x. So the function is continuous there, and because the interval is closed, we know that the function attains its extreme values on that interval, and the points where the extreme values of f are attained, it can be either the endpoints of the interval or the critical numbers of f. So we start by calculating the first derivative of f, and that's a product here. We have x squared x to the negative 2 times natural logarithm of x. We can see it also as a fraction, as a quotient, like natural logarithm of x over x squared. But let's see it like a product, and then we apply the product rule for differentiation. So we get the derivative of x to the negative 2 is negative 2x to the negative 3 times the natural logarithm of x plus x to the negative 2 times the derivative of natural logarithm of x, which is 1 over x. So we get negative 2 natural logarithm of x over x cubed is the first term here, plus 1 over x cubed, and that becomes 1 minus 2 natural logarithm of x over x cubed. So that's the derivative, and this derivative is not defined as 0. That does not exist at 0, and in fact is also defined only for positive values of x. So 0 is not a critical number of f because even though the derivative does not exist there, that value 0 is not in the domain of the function. So we can say that f derivative at 0 does not exist. But 0 is not in the domain of f, so it is not a critical number of f. So we gotta solve the equation. First derivative of f equals 0, and that's the same as the equation 1 minus 2 natural logarithm of x over x cubed, and we are supposing on these equivalences here that x is positive, so that we can take the natural logarithm. So this is equivalent to the equation 1 minus 2 natural logarithm of x equal to 0, which is equivalent to natural logarithm of x equal to 1/2. And because the exponential function is injective function, we get that for the positive numbers, we get that this is equivalent to e to the natural logarithm of x equal to e to the 1/2, and this is equivalent to, because the natural logarithm and the exponential function are inverse to each other, we get x equal e to the 1/2, which is the square root of e. And if we calculate that, it's about square root of e is about 1.6487, 1 to 1 to 7 07. Okay, this is so this is the only x equal square root of e is the only critical number. Let's see, in fact, that this number is in the interval 1/2 4, because 1/2 is 0.5, so between 0.5 and 4 is the number 1.6487. So it's the only critical number of f in the interval 1/2 4. In fact, it's the only critical number of the function in its extended domain, which is a positive numbers. Okay, so we have this, and now we can find the extreme value of the function by evaluating the function at this critical number and at the endpoints of the interval, that is 1/2 and 4. So what we have here is f at 1/2 is equal to, let's see, x to the negative 2 times natural logarithm of x. That's the same as natural logarithm of 1/2 over 1/2 squared. And remember, the natural logarithm of a fraction is the natural logarithm of the numerator minus the natural logarithm of the denominator. That's a property of the logarithms. And 1/2 squared is 1/4. Natural logarithm of 1 is 0, so we get negative natural logarithm of 2 over 1 over 4, and that's negative. That's negative 4 natural logarithm of 2, which is about negative, that value is about negative 2.772 5887. Let's put it a little bit to the left. That's about 2.772 5887 2224. 3 times 2, 4. Okay, now f at the other endpoint, that is at the right endpoint, is 4, and that is natural logarithm of 4 over 4 squared. Remember, 4 here is natural logarithm of 2 squared over 16, and this, applying the properties of the logarithm, we get 2 natural logarithm of 2 over 16, and that's the same as natural logarithm of 2 over 8, and that's about 0.08664. Okay, and that's the endpoints. Now the critical number is square root of e, and the image is natural logarithm of the square root of e over square root of e squared, and here we get 1/2 over e, that is 1 over 2e, which is about 0.1839397 206. So between these values is the absolute minimum and the absolute maximum values of the function, and we recognize easily that the absolute maximum value of the function is 0.1839397 which is 1 over 2e, and it is the image of the critical number square root of e, and the minimum value is the absolute minimum value of the function is negative 4 natural logarithm of 2, which is about negative 2.772588722224, which is the image of the left endpoint 1/2. So we can write the answer to the problem. We can say that the absolute minimum value of f on the interval 1/2 4 is we said negative 4 natural logarithm of 2, which is about negative 2.7725. Sorry, it's 2.7725 887 2224. And that minimum value occurs at the left endpoint 1/2. And on the other hand, the absolute maximum value of f on the closed interval 1/2 4 is 1 over 2e, 1 over 2e, which is about 0.183939 7206 7206, which occurs at the critical number x equal square root of e, which in fact is more or less equal to 1.648721 2707. So this is the final answer to the problem. And we remember what we did here. We first recognize that this function is continuous over the closed interval, so it attains its extreme values at that interval. And knowing that those extreme values are attained either on the endpoints of the interval or at critical numbers of the function, we calculate the first derivative of f and see if there are values in the domain where the derivative is not defined, and it's not the case here. That is, even though 0, for example, is a value where the first derivative does not exist, that value 0 is not in the domain of the function, so it is not a critical number. And we saw that in fact the function and its derivative are defined for positive value of x. 0 is not included, so but the given interval is completely in the interval, or is contained in the interval of positive numbers, so the derivative exists for all values of x in that interval in this case. So the only critical numbers here are those for which the first derivative is 0. We state that equation, and then we solve it to find that the only critical number of the function in the interval 1/2 4 is x equals square root of e, which is about 1.6487 to 12707. Then we evaluated the function at the endpoints of the interval and at the critical number square root of e, and we found that the largest value is 1/2e, which is about 0.28 0.1839397206, and it occurs at the critical number square root of e, and the smallest of the values is -4 times natural logarithm of 2, which is about -2.77258887 to 224, and it occurs at the left endpoint of the interval 1/2. And so we have found the absolute minimum and absolute maximum value of the function over the given interval.